Alright, classic Meg riding her motocross bike, going for some mad hoons. So this problem, as we'd expect, is a kinematics problem, right, to deal with motion. So when Meg passes a fixed point on the track, she has a certain speed, right, 5 meters per second, and a constant acceleration of 0.6 meters per second squared. So if she was to continue to accelerate at this rate, what is her speed when she has been riding for 10 seconds after passing that point P? So if you take physics, this is just a kinematics problem, and you can actually solve it using the kinematics equations, but we'll actually be able to derive that equation using calculus. So let's have a think. So remember, kinematics is all about relating like distance or displacement, speed, and acceleration, right? So the derivative with respect to time of distance gives velocity, right? The rate of change of velocity gives acceleration, but we can also anti-differentiate or integrate to go the other way. So in part 1, we know that her acceleration is 0.6, right? It's that same rate. So as an equation, her acceleration is 0.6. Rereading the question, it's asking what is her speed. So we need to work out the equation for her speed. So again, we are given acceleration. To find speed, we anti-differentiate. So velocity is 0.6 t, right? Instead of dealing with x in a kinematics problem, we deal with time. So the antiderivative of 0.6 is 0.6 t. All right, are we done? Absolutely not, right? Plus c. Now this plus c is just some constant which we can solve for using a point, right? And instead of an xy value, we need a t v value, right? We need to know her speed at a certain point. So let's reread the question. I see she has a speed of 5 meters per second. And what time would that be? So the question asks what her speed is 10 seconds after passing P. So it would make sense when she's at point P for us to start the timer, right? Time is 0. So using the TV value of 0.5, right? Initially at time 0, she's moving at 5 meters per second. Let's substitute in the values and solve for C. So V is 5, 0.6 times T was 0, plus C, that goes to 0, C equals 5. Which makes sense, right? Initially, she's moving at 5 meters per second. So we would expect the plus C to be 5. So this gives us with V equals 0.6 T plus 5. Cool. Alright, and the question asks what is her speed 10 seconds after passing that point? So we can substitute in 10 seconds for T into the speed equation. 0.6 times 10 is 6 plus 5. So her speed will be 11 meters per second. Awesome. So just to recap that, it was a little bit hard to work out or to recognize that we were given the equation for acceleration because it was constant. However, having a equals 0.6 as our acceleration equation is perfectly fine. Right? We then anti-differentiated it. So So I guess step one, we acknowledged what our acceleration equation was. We anti-differentiated it to get the velocity, or the speed equation. So at this point, that would be achieved. We then solved for c, and then also substituted in 10 seconds to find the final velocity, which would be merit. Okay. And the mark scheme actually says if you just use the kinematics equation, like from physics, you would get nothing. Right? Sorry about that. However, while we're here, just looking at the equation that we derived using calculus, it is very similar to v final equals v initial plus at. Right? And that's actually where it comes from. Alright, following on from part 1, we're asked how far will she have travelled from P when she reaches a speed of 8 meters per second. So ultimately we are looking for a distance, and so far we have her acceleration equation. We also have her velocity, right, her speed equation, but we don't yet have her distance equation, so we know we're going to need to work that out. So in fact, let's start with that. So we were given acceleration initially as 0.6. We anti-differentiated and substituted in a point to solve for speed. We can now do the same but for distance. So we know the speed equation, 0.6t plus 5. Distance will be the antiderivative of that, which is 0.6t squared over 2 plus 5t plus c. And 0.6 over 2 is 0.3. Awesome. So now we need to find a point to solve for c. Just like in part 1, we found a time speed point. In part 2, we need a time distance point. So at time 0, so initially, what is her distance from point P? So initially, her distance from point P is 0, because that's where we start the clock and start measuring her motion from. So we would use, so TD is 0, 0 to solve for C, and in fact when we substitute it in, we will see that C equals 0. So we get C equals 0, right, because her initial distance is 0. That's what the C represents. So as an equation, we know her distance is given by 0.3 t squared plus 5t. Right, and we're in a good position. So we have equations for both, or for all of distance, speed, and acceleration. Alright, now back to the question. We are looking for a distance, but we're looking for the distance when she's at a speed of 8 meters per second. So looking at our distance equation, I don't see speed anywhere, right? Our only input is time. So that tells me we need to find a time. The time that corresponds to a speed of 8 meters per second. Well, do we have a way to relate speed and time? Absolutely, right? All that hard work in the last question. So we want her speed to be 8, and then we will equate it to 0.6t plus 5. Right, that is our speed equation. So when we solve for t, that is the time when she reaches a speed of 8 meters per second. So subtracting 5 off both sides. What is 0.6? That's 6 over 10. You can of course use your calculator. So timesing by 10 gives 30, dividing by 6 gives 5. So at 5 seconds, her speed will be 8 meters per second. Now, combining these two facts, right, our distance equation in terms of time and the time we're interested in, we can solve for distance. So 0.3 times 5 squared plus 5 times 5. 0.3 times 25 plus 25. What's that? 3/10 times 25. So that's 2.5, 7.5 plus 25, 32.5 meters. Whew. Alrighty, so just to recap that question, it was a little bit odd. They asked for a distance when she was traveling a certain speed. So the two parts to the problem were, one, we found the distance equation by anti-differentiating the speed equation. We also acknowledged that at time 0, her distance is 0 because we measure from that point P. Then step 2 was finding the time at which she's traveling at 8 meters per second. So if we got both of those things, that is merit. Right? If we just got actually this first step, that anti-differentiation, that would be achieved. But then combining the two to find the distance traveled would be our excellence component. Alright, and the final part of this question. So Leo was riding with Meg, but he begins to decelerate at that time, right, when they reach a speed of 8 meters per second. If he decelerates at 0.2 meters per second squared, how far past the point P will he be when he reaches a speed of 6 meters per second? Right, so he's traveling along at 8 meters per second. He starts to decelerate, so speed decreases until he's at 6 meters per second. And we want to find the total distance past the point P, right, after he's decelerated and he's reached a speed of 6 meters per second. Alrighty. Alright, where to begin? So let's just acknowledge that this is part 3 of the same question, which means some of the work we've done before will help us. Right, so namely, just how this is worded, Leo was riding with her up to the point before 8 meters per second. Or they were traveling 8 meters per second. So that's all the way up to part 2. Right, so Leo and Meg both traveled 32.5 meters, right until the speed of 8 meters per second. However, from that point, Leo started to decelerate, whereas Meg assumedly keeps accelerating, or maybe flattens off and just goes at a constant speed. Cool. So instead of tackling the whole problem again, we know that Leo would have traveled 32.5 meters in the first, the first 5 seconds. Yep, so that's from part 2. Cool. So now let's work out Leo's section from there. So we have a new starting point, right? Maybe point Q. and then we'll factor in that extra distance at the end. So like before, we are given his acceleration. However, this time it's negative 0.2 as he's decelerating. Right, so we're given acceleration. So we can anti-differentiate to get velocity. Cool. Just a reminder, the question is asking for a distance, so we're going to want to get our distance equation for Leo eventually. So anti-differentiating to get velocity would give us minus 0.2 t plus c. Right, don't forget the plus c. And just rereading the question, his initial speed at this point is 8 meters per second. So I know c will be equal to 8. But just like before, we could use the point 0.8, right, initially, so t equals 0. Substitute in 0 for t, 8 for v, we find that c equals 8. So we're given his speed is minus 0.2 t plus 8. Cool. Alright, now we do need his displacement, right, or his distance. So we need to anti-differentiate the speed equation. So anti-differentiating that, we get minus 0.2 t squared divided by 2 plus 8 t plus c. Alright, so just simplifying that coefficient at the front becomes minus 0.1. Now, what point will we substitute in here to find c? So it's actually similar to the first problem, or excuse me, the second problem, where we substituted in 0, 0. So from, there we are. So from Leo's perspective, right, we made this new point Q, and initially he is 0 meters from it at time 0. So use 0, 0, and we find obviously that his initial distance is 0. In other words, c is 0. So his distance equation is minus 0.1 t squared plus 8t. That's not from point P, right? This is from Q. So we have P, they travel some distance, and now we're considering this section here, right? Cool. So now, again, let's reread the question. How far past the point P will he be when he reaches a speed of 6 meters per second? So we have the distance equation, but again, to find distance we need time. However, the question is asking when he's at a speed of 6 meters per second. So let's use our speed equation. I'll just split off here. So when his speed is 6 meters per second, we can solve for that time. Right, so I equated 6, so v equals minus 0.2 t plus 8. Subtracting 8 from both sides, and dividing both sides by negative 1/5 will give us t equals 10 seconds. So at 10 seconds, Leo is traveling 6 meters per second from point Q. So let's combine these two. to find the distance from point Q that Leo has travelled. So negative 0.1, 10 squared plus 8 times 10. What's that? 100 times a negative 10th gives negative 10 plus 80 gives 70 meters. So this section right here is 70 meters, but we already worked out in the first section as 32.5 meters. Right, so our final answer, therefore Leo travelled so that 32.5 plus 70, 102.5 meters from point P when he was travelling at 6 meters per second. I guess that's actually for the second time, right? Because he would have had to accelerate past 6 meters per second to get to 8 meters per second and then decelerate some more. Right, but just from the context of this question, right, it's inferred it's that second point. Alrighty, so let's recap this one. Quite a lot involved. So first up, we found the acceleration equation, right, is negative 0.2. We anti-differentiated that to get the speed equation, and at that point, that's actually achieved. We anti-differentiated again to find the distance equation, and at the same time, over here, we worked out the time at which they were traveling at 6 meters per second. So if you did 3 and 4, that would be merit. Then finally, putting those facts together, we found out the distance Leo traveled in the second section, right, from point Q was 70 meters. Therefore, the combined distance, our conclusion, was he traveled a total of 102.5 meters. And there is a way that you could actually model this in one go, right, from point P all the way to the end without doing it like we did from point Q. So I encourage you to try find that way as well. And of course, once we got the final answer, that is our excellence point.